Hello and welcome back. Next up, we've got Liz Parody. Liz is a community taught software engineer focused on JavaScript and the head of developer relations at NodeSource, where, amongst other things, she is the interface with the general open source community for general planning and evolution of the Node.js open source project. She's the organizer of JSConf Colombia and a huge supporter of women in tech, and also organizes the biggest meetup for women in tech in Colombia, Pioneers Developers, as well as being the organizer of the first Startup Weekend Women's Edition. She loves sharing knowledge, promoting JavaScript and Node.js ecosystem, and participating in key tech events and conferences to enhance her knowledge and network. Please welcome Liz Parody, who will be examining observability in Node.js. Hello, Liz.
Hello all. Hi. Thank you. I'm very happy to be here. Today I will be talking about examining observability in Node.js. My name, as mentioned before, I'm Liz Parody and I'm head of developers relations at NodeSource, and I am from the beautiful country of Colombia. So this is the agenda for today. First, we're going to talk about what is observability, then why observability is important, how we can use Node.js internals for observability, including performance hook, trace events, Heap snapshot, BA native module, and then we will look at some external tools for observability, benchmarks, and conclusions at the end. So let's begin by understanding what observability is and why it is important. Observability is a term from control theory. According to Wikipedia, is a measure of how well internal states of a system can be inferred by the knowledge of its external outputs. In other words, we can see the results or the outputs, and then we can know what's happening on the inside. Let's take, for example, bananas and avocados. In Colombia, we have a lot of bananas and avocados, and just by looking at the outside, we can know how it's on the inside, if they're ripped or if they're not ready for consumption yet. In software products and services, observability means that you can answer any questions about what's happening on the inside of a system by observing or by asking questions from the outside of a system without needing to ship new code or to answer questions. And that's very important because we shouldn't need to write new code to observe what's happening inside of our system. System complexity is outpassing our ability to predict what's going to break. There are super useful tools that come to the rescue. And talking about system complexity, software is becoming exponentially more complex. In infrastructure, we're seeing things like microservices, polyglot persistent, containers, Kubernetes, Docker, and others that decompose monoliths into microservices that are great for products but hard on humans. And the number of products of tools are also multiplying. There are countless of platforms and tools for empowering people to have better observability and control over the code. Great for users, but it's hard to choose which one is the best one. To successfully deliver and run a product or services under these escalating conditions, you need observability. Now that you know what observability is, you will be wondering why it's important and why you should care. With environments as complex as we see today in modern applications, just monitoring for problems is not enough to recognize and fix the number of issues that arise. Sometimes the new issues are unknown unknowns, which are problems you don't know, and even worse, problems that you don't know how to find. So without tools to observe the environment, it's almost impossible to solve the issues. This is why observability is important. It gives you the instrumentation you need to understand what's happening inside of the software and fix it. So a good observability tool it helps you find what and where the problem is. It just doesn't tell you, yeah. It also doesn't add overhead to your app because we don't want our app to slow down, quite the opposite. It also has enhanced security because we don't want our NPMs to make some data breach. Has flexible integrations and doesn't need to modify your code. It's important to differentiate between observing and also monitoring. There are two different things. So observing is exposing internal states to be viewed externally, but monitoring in the other side is collecting and displaying the information that has been exposed, and it usually involves some writing automation tools around that. So now Let's imagine your productivity and confidence developing web apps without Chrome DevTools. Many do that exactly with Node.js. I think every web developer on the planet has used Chrome DevTools at some point, but not a lot of Node.js developers has used similar tools to observe and fix their Node.js applications. So if you want to solve the most complex Node.js problems such as memory leaks or performance issues, or even just to follow the best practice to keep your code healthy, it's necessary to have an observability tool. The next step will be choosing an observability tool that adapts the best for your needs. So choosing an observability tool. First, we're going to see which observability tools can be used in Node.js internals, and then we're going to check some external tools. There are different layers of observability tools. First, we can use for internal service host, and finally the cloud network. In Node.js internals, the first one that we're going to see today is performance hooks. This is a particularly helpful for checking on performance, as its name says. It's an object that can be used to collect performance metrics from the current Node.js instance. Performance monitoring is not something you should start considering once you start seeing performance issues. Instead, it should be part of your development process in order to detect problems before they arrive in production. Because of the asynchronous nature of Node.js, code profiling with regular tools can be challenging, especially because part of the time you could be outside of your code and it can be inside of the event loop itself. So that is important to use some internal Node.js tools like performance hook or external tools as we're going to see later. So let's do a little demo here. Let's measure for example, the performance of the 4 biggest search engine in the world: Google, Yahoo, Bing, and DuckDuckGo, using performance hooks. So we have here performance observer for performance hook. Then here we're just going to loop through these URLs, and using performance observer, we're going to check like the performance and the time execution of those 4 search engines. So if we do this, we can see the fastest one is Google, followed by Bing, and then DuckDuckGo, and the slowest one, according to this script, is Yahoo. These times are in milliseconds. Let's look at another example. This one is just simply a simple Hello World app, but just using performance observer, and we're just going to measure the execution time of this very simple Hello World app. And here, I will just do. And this Hello World app takes 10 milliseconds to execute. So while performance hooks are very informative, there are some trade-offs because it requires instrumentation of your code manually, impacting readability. In case of performance observer, there are significant overhead costs to the observing. The next one is profiling. If we use the flag prof process, it will generate a log file. And this can be used to get like more human readable information like flame graphs. Flame graphs helps you see where are you spending time on your application. This can be very productive in getting insight of what's going on in your application, but the downfalls is that it has significant overhead, plus generating new files can be tricky. But you can extract like a lot of information here. The next one, it will be trace events. The trace events provides a mechanism to centralize information generated by V8 Node Core and user space code. Tracing can be enabled with the trace event flag command line that accepts a list of comma-separated categories named by using the trace event module. By default, Node async hooks, and V8 categories are enabled. You can execute trace event enable flag to get the output of several events that happen inside Node.js. This can include accessing the file system, performance data, or async hooks, and others. You can configure which events you want to see by using the flag trace event categories, allowing users to create custom trace events and use them, for example, to see how long our operation takes. In Chrome, we can open this Chrome tracing, click the record button, and then it will allow you to visualize tracing like this. If we look at the bottom of the screen, you can see fs, sync, read, and this is a read operation of the file system. There are 546 bytes read. It's also possible to see when the tracing started, how long it took, the CPU duration, which is a very useful seeing what's going on with your code. This is another example of tracing, but using more processes and multiple threads. Here we are looking at the main thread and different useful information like direct time, processes that depend on other processes, arguments, and others. Tracing has less overhead profit, but management of the files becomes harder because this is looking at a lower level instrumentation of Node.js internals. The next one will be heap snapshots. A heap snapshot is a static snapshot of a memory usage detail in a moment in time, and it provides a glimpse into the heap usage of V8, the JavaScript runtimes that power Node.js. By looking at these snapshots, you can begin to understand where and how memory is being used. Heap snapshots are very useful for finding and fixing performance issues in Node.js applications, especially memory leaks that sometimes are super hard to find. A few years ago, developers had to use heap dump module to obtain heap snapshots. But today, we have a built-in heap snapshot signal flag, which is heap snapshot signal, this one here. So you can set as many signals as you want. So, as I was saying, that a few years ago, developers, they have to use the dump module to obtain heap snapshots. But right now, we have this flag heap snapshot signal, so you can send as many signals as you want, and Node.js will dump the heap snapshots. Chrome DevTools allows you to compare snapshots, and you can identify objects in memory that will help you narrow down when there is a memory leak that might be occurring. So this is how it looks like. And this is how it looks in a very high level. The column of the far left, objects of the JavaScript heap. On the far right, you can see the objects count column will represent how many objects are in memory. Also, the shallow size column, which is the amount of memory allocated to store the object itself. And the retain size column, which is the shallow size plus the shallow size of the objects that are accessible only from this object. In other words, the retain size represents the amount of memory that will be free the garbage collector the object is collected. The next one that we're going to see, V8 Inspector. This is not an observability tool, but instead it's a development tool that helps you monitor what's happening in your application. A few years ago, Chrome DevTools was integrated directly into V8, expanding its capabilities to include Node.js applications. With this integration, it was possible to access step debuggers without having to install the Node.js inspector, the Node Inspector module. There are a few ways to get started. One is using the inspect flag, which starts the inspector. Then you can pass a port, this one, that you can listen it, inspect, host, and port. But if no parameters are passed, it would use the default, which is in this case 127 port by default. One other way is more useful when doing local development using the inspect break flag. This flag has set the same options for host and port than the inspect flag, but also puts a breakpoint before the user code starts. So you can do any type of setup you prefer without having to try catch breakpoints as you could at runtime. So let's look by a little demo here. Okay. The BA inspector here, I'm just creating a new error. It's called a new cool error here, using promise reject. If I want to use that break flag, I just do something like dash inspect break and the name of the file. And then we can see that the message printer is that debugger is listening to this WebSocket URL. WebSocket makes possible to open a two-way interactive communication session between the user browser and the server. We can also see a message that directs the user to the Node.js communication here, so we know what's happening there. Okay. Okay. If we go to the URL cram inspect, you will see something like this. And once you click on that, you will see a dedicated DevTools for Node.js link. That will pop up a window for debugging your Node.js sessions. And as you can see in this image. DevTools is now connected to your Node.js just by using that link, providing you with access to all of the cram DevTools features we are all used to. This allows you to edit pages on the fly, access source maps for file code, live edit, concept evaluation with EXE's feature object, sampling JavaScript profile with flame graph, heap snapshot inspection, heap allocation timeline, asynchronous stacks for native promises. However, the V8 should never be used because DevTools actions, this is acceptable for development, but is unsuitable for production environment. For production environments, we will see later which is the best option. Some of the problems with things that Node.js already provides with Node.js internals, like profiling, performance hooks, and others, is that it tells you that there is a problem, but it doesn't tell you where to find it. Also, sometimes they're not easy to implement. Give you no information, or is not presented in an easy way, like graphs or center performance metrics that other external tools provide. Also has significant overhead, generally not viable in production. And also it provides data overload, which means there is a ton of data and it requires expertise to separate signal and significant data from noise. There are also some pros because those are great tooling and they have extensive data and documentations and can give you a lot of insights. The ability to correctly monitor the process is limited on how much data exposed. How data is exposed is the observability tool that we're going to see next. So external tools for Node.js Obs. The block npm package is a concise example of using timers for observability. It'll help you check if the event loop is blocked. But it doesn't tell you where. It's useful for understanding the overall health of the event loop. It can have positives in some scenarios because of the timeout offset. In addition, it can also create numbing effect, alerting you event loop blocks, but not signifying or telling you what's actually causing the blockage. Many times developers just ignore it as there's no clear action. New Relic is an observability platform built to help engineers create better software. From monoliths to serverless, it helps instrument everything, analyze, troubleshoot, and optimize your entire software stack, all from one place. It also provides different solutions from cloud adoption to digital customer experience and different industries, just to name a few. This is how New Relic insights appear. You can see web transformation time, the application activity, error rate, host, and others. We also have Datadog. Datadog is very popular. It's a monitoring services for cloud scale applications, providing monitoring of servers, databases, tools, and services through a SaaS-based data analytics platform. With Datadog, you can check requests, latency distributions, error, percentage of time, and others, as we can just see here. The next one is Instana. It's an application performance monitoring for microservices. It lets you manage the performance of your application in real time and see every detail about the inner workings and inner dependency of your applications. It helps you trace events, distribute requests, map all services, profile every production process, as we can see in some of the metrics like false calls, error, mean latency, top services, processing times, and others. There's also an external tool called Dynatrace. Dynatrace produces a software intelligence platform based on artificial intelligence to monitor and optimize applications performance and development, IT infrastructure, and user experience. They focus mainly on these 5 categories: advanced observability, continuous automation, AI assistant, cross-team collaboration, and user experience and business analytics. For Node.js observability, it can tell you the number of processes, CPU and memory usage, the percentage of connectivity, availability, and others. I can't move my screen. What's happening? My second screen is acting weird today. I cannot move the slide. Oh no, what's happening? One second. It's been acting fine always, and today it just broke. My second screen. Okay, but I can just keep going. So, Google Cloud for Node.js monitoring. The next one is Google Cloud. It was before called Stack Driver that provides monitor, troubleshooting, debugger, error reporting. But there is a problem with all of these solutions. The way that APM works is because they become agents. So they're just agents that or intermediaries between your application and the Node.js runtime. The APM is injected into your code and it encapsulates your application so they can extract the information. And that has a significant cost, also known as overhead. I have heard that sometimes the APM itself is the one that creates the performance problem. And as you can see, APM code and overhead, the time provide. Like CPU profiles, stack traces, and others, you can see the APM code and cost. Another problem is that sometimes you have to modify your own code in order to implement the APM or the observability tool, which create extra work and extra layer of difficulty that we don't want to deal with. Also, the accuracy is questionable. But they can be very useful tools that provide you with additional insights and extensive data and insight. But there's one tool that doesn't have this problem because it's not an APM. It's an enterprise runtime for Node.js, and it adds minimum overhead, and you don't have to modify your code at all. So this solution is called NSolid, which is a drop-in alternative for the Node.js runtime, enhanced to deliver low-impact performance insights and greater security for mission-critical Node.js applications. So it has faster time resolution, a stronger infrastructure, hardened security, zero code instrumentation. That means you don't have to change your code in order to implement it, and it also has minimum performance overhead. So, as the conclusions, I was going to show you some benchmarks about, but I cannot show you because my screen is not working. I don't know why. but I will share the screens. And as a conclusion, observability in Node.js is very important for security and performance. It allows you to filter faster. And if you are focusing in Node.js specifically, NSolid is the best observability tool out there. It's the fastest one, is the more secure. And other tools are great, but they come with a cost because they are not also they have great overhead from wrapping the user's codes into their own libraries. NSolid avoids these penalties by observing the application at a lower level, allowing NSolid to make observations without directly affecting how the program runs. For other types of application, and depending on the needs, there are some other great observability tools that can add a lot of value. So I'm sorry for the technical issues. I will share the screens with all of, I will share the slides with all of you. And if there's any questions, I will be very happy to respond them.
And well done for recovering from some horrific technical problem there. Congratulations on doing a great job of carrying on, because that is hard work. So thank you. I'm afraid we're not going to have time to ask you questions here, but you are available on Twitter, and is that where you'll be sharing your slides as well? Oh, yeah. Amazing. Thank you ever so much. It was a really interesting talk, and I look forward to hearing your answers to people on Twitter.
Yes, for sure. Thank you so much.